we shall discuss about Fourier series. Fourier series ಗೆ ತಿಳ್ಕೊಳ್ಳೋದಕ್ಕಿಂತ ಮುಂಚೆ ನಾವು periodic functions ಅಂದ್ರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. Because most of the times we will be using periodic functions to represent by Fourier series. ಕೊಟ್ಟಿರತಕ್ಕಂಥ periodic functions ಗಳನ್ನು Fourier series ನಾವು Fourier series ಅಂತ ಕರೀತಕ್ಕಂಥದ್ದು ಏನು ಅಂತಂದರೆ it is a sum of sine and cosine series. Sine and cosine series. ಸೊ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಫಂಕ್ಷನ್ನು ಪೀರಿಯಾಡಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಆಗಿದ್ದರೆ ಅದನ್ನು ನಾವು ಸೈನ್ ಮತ್ತು ಕೋಸೈನ್ಸ್ ಫಂಕ್ಷನ್ಸ್ಗಳಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೇವೆ. ಸೊ ಇದು ಫೋರಿಯರ್ ಸೀರೀಸ್. ಸೊ ಅದಕ್ಕೆ ಪೀರಿಯಾಡಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಅಂದರೆ ಏನು ಅಂತಂದರೆ ಎಫ್ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ಟರ್ ಸರ್ಟನ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಎಕ್ಸ್ ರಿಪೀಟ್ ಆಗ್ತವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, if you take sin x, sin x is equals to sin x plus 2 pi. For example, x is equal to 30 degree ಇತ್ತು, or x is equal to pi by 6 ಇತ್ತು. You may note that sin of pi by 6 is equals to sin of pi by 6 plus 2 pi. So after every interval of 2 pi, the value of sine function repeats itself. Such functions are called as periodic functions, and the length is called as period. In other words, if f of x is equal to f of x plus L, where L is any real number, then L is called as period of the function. Of course, if you take sin pi x divided by k, here the coefficient of x is pi by k, and you may note that it is equals to sin of pi by k x plus 2k. So here we may note that the given function repeats after length of 2k. In other words, sin pi x divided by k is a periodic function with a period 2k. So there are a lot of such periodic functions. We may note that tan x is a periodic function with a period of n pi. Cot x is also periodic function. Cosecant x, secant x, cos x, and all those are periodic functions. Of course, the period of the functions may be different, but those are all periodic functions. And of course, we note that the sum of the periodic functions is again also a periodic function. Sum of the periodic function is also again a periodic function. In case of Fourier series, if fx is a periodic function defined on some interval, we use Euler's formula and find the Fourier series expansions. Here there are two kinds of Euler's formula. One is basic Euler's formula and another one is modified Euler's formula. The basic Euler's formula is used when the function is defined on an interval of length 2 pi, and the given function is defined on a length of interval 2 pi. For example, if fx is defined on the interval, that is for all values of x in the interval 0 to 2 pi, for every x contained in the open interval 0 to 2 pi, here the length of the interval is 2 pi. If the given function fx is defined on the interval minus pi to plus pi, Again the length of the interval is 2 pi. If the given function is defined for every x in the open interval minus pi by 2 to plus 3 pi by 2. Here again we know that the length of the interval is 3 pi by 2 minus of minus pi by 2, that is again equals to 2 pi. So whenever the function is defined either on the interval minus pi to plus pi, or the function is defined for all values of x in the interval 0 to 2 pi, or the function may be defined on the interval of length minus pi by 2 to 3 pi by 2. In all these cases we use basic Euler's formula. Now we shall discuss what is the Euler's formula. Suppose f of x is equal to f of x plus 2 pi and fx is defined on the interval say c to c plus 2 pi. C is the initial point of the interval, c plus 2 pi is the end point of the interval, and the length of interval is 2 pi. So when fx is defined for all values of x in the interval c to c plus 2 pi, Euler's formula says fx is equals to a naught divided by 2 plus summation of an into cos nx plus sum of bn into sin nx. All these a naught, an, bn are constants and can be calculated by simple integration. A naught is equal to 1 by pi integration from c to c plus 2 pi fx dx. You note that fx is defined on the interval c to c plus 2 pi. So here the integration is also from c to c plus 2 pi. Similarly, an is equal to 1 by pi integration from c to c plus 2 pi fx into cos nx dx, and bn is equal to 1 by pi integration from c to c plus 2 pi fx into sin nx dx. ಇಲ್ಲಿ an ದೊಳಗೆ fx ಕೋಎಫಿಷಿಯೆಂಟ್ cos nx ಇದೆ, ಅಲ್ಲಿ ಸೀರೀಸ್ ದೊಳಗೆ ಕೂಡ an ಕೋಎಫಿಷಿಯೆಂಟ್ cos nx ಇದೆ. ಇಲ್ಲಿ ಸೀರೀಸ್ ದೊಳಗೆ bn ಕೋಎಫಿಷಿಯೆಂಟ್ sin nx ಇದೆ, ಅದಕ್ಕೆ ಇಂಟಗ್ರೇಷನ್ ದೊಳಗೆ bn ದ ಇಂಟಗ್ರೇಷನ್ ಫಾರ್ಮುಲಾದೊಳಗೂ ಕೂಡ fx ಕೋಎಫಿಷಿಯೆಂಟ್ sin nx ಇದೆ. So you must remember, and when n is equal to 0 you may note that cos of 0 is 1, so it will give you a naught is equal to 1 by pi integration from c to c plus 2 pi fx dx. So using these expression for a naught, an, bn, we will find the coefficients and substitute in the series expression fx is equal to a naught divided by 2 plus sum of an into cos nx plus sum of bn into sin nx. So let us take one example. ಈಗ ಇಲ್ಲಿ ಎರಡು ಸ್ಟೆಪ್ ಇದ್ದಾವೆ. ಒಂದನೇದು fx must be defined for all values of x in the interval c to c plus 2 pi. The length of the interval is 2 pi. ಅದನ್ನು ಮೊದಲಿದ್ದ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. fx is defined on the interval of length 2 pi, whether it may be a closed interval or may be open interval. Second thing, we will be calculating a naught is equal to 1 by pi integration from c to c plus 2 pi fx dx. An is equal to 1 by pi integration from c to c plus 2 pi fx into cos nx dx, and bn we calculate using the formula bn is equal to 1 by pi integration from c to c plus 2 pi fx into sin nx dx. So first step nalli length of the interval fx ತಗೊಳ್ತೀವಿ, ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ನಲ್ಲಿ a naught an bn ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ, ಥರ್ಡ್ ಸ್ಟೆಪ್ ನಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ a naught an bn ವ್ಯಾಲ್ಯೂವನ್ನು ಸೀರೀಸ್ ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಸೀರೀಸ್ the given series is fx is equal to a naught divided by 2 plus sum of an into cos nx plus sum of bn into sin nx. So let us take one example. Find the Fourier series for fx is equal to 1 for all values of x in the open interval minus pi to plus pi, and it is also given that f of x is equal to f of x plus 2 pi. So here the given function is periodic function with the period 2 pi, but the function is defined as 1 in the interval minus pi to plus pi. So for all values of x in the interval minus pi to plus pi, fx value is 1. So we will calculate the coefficients a0, an, bn by writing a0 is equal to 1 by pi integration from minus pi to plus pi fx dx, which is equal to 1 by pi integration from minus pi to plus pi 1 dx. We will find that a0 is equal to 2. Similarly, we will calculate an. An is equal to 1 by pi integration from minus pi to plus pi fx into cos nx dx. fx is equal to 1 ಇರುವುದರಿಂದ this interval minus pi to plus pi ದಲ್ಲಿ fx 1 ಇರುವುದರಿಂದ it is again equals to 1 by pi integration from minus pi to plus pi cos nx dx, and its value is 2 sin n pi divided by n pi. You may note that sin of minus theta is equal to minus sin theta. So sin n pi minus of minus sin n pi. So that becomes 2 sin n pi divided by n pi. So here sin n pi is 0. Sin n pi is 0. So its value an value also becomes 0. Hence for the given function we get a0 is equal to 1, an is equal to 0, and bn is also 0. As bn is equal to, we need to consider here 1 by pi instead of 1 by 2 pi. It is wrongly written. Bn is equal to 1 by pi integration from minus pi to plus pi fx into sin nx dx. You make a correction. Bn is equal to 1 by pi integration from minus pi to plus pi fx into sin nx dx, and as fx is equal to 1, its value will be 1 by pi integration of sin nx dx over the interval minus pi to plus pi, and its value becomes 0. So we know that a0 is equal to 1, an is equal to 0, and bn is equal to 0. So substituting all these values in the series, we can write fx is equal to 1 plus summation of 2 sin n pi divided by n pi into cos nx plus 0. Of course, as I told earlier, sin n pi is also 0. So both the terms in the sum will become 0, and we retain only 1. So here LHS fx is 1 in the interval minus pi to plus pi. So RHS is also 1. So this is the verification.